Hello, everyone. Good
Good
evening.
evening, sir.
Good evening,
Good
sir.
evening. Good evening. Okay, let's start our class. Okay, so yesterday we saw about electrolyte and insulator. Insulator, they have high resistivity. They have high resistivity. So with that, their conductivity becomes almost zero, near to zero. In short, like it's not zero, it becomes almost zero. So see, in some case, it can conduct, like in presence of some EM waves, some X-rays or any other waves, it can conduct. Some insulators, like air, air is also insulator. It may conduct, but in some cases, because if air is an insulator, and if it conduct every time, then we cannot stay alive. We'll be pretty dead, because even we are charging anything, whatever we are doing, it's get detected and we get shocked with that. So insulators, they don't have free electrons, first of all. It has high resistivity. So that because of that, conductivity of insulator is almost zero. Now next is our superconductor. Superconductor is like a very negligible resistance. Every material have resistance, but even we can say every conductor also has resistance. But we can say like a superconductor is a material resistance becomes zero. Okay, but for reaching at that point, there should be some temperature. So that temperature, at certain temperature, that temperature is called critical temperature. If it goes beyond it, beyond in the sense below it, I mean to say below it, it will become superconductor. Superconductor means like which has zero resistance, which makes 100% flow of electron. So if there is a material, okay, obviously there will be some disturbance here. So flow of electron is not that much easier. So in superconductor, the resistance becomes zero below certain temperature. So uses, it is used in making a very strong magnet. In making very strong magnet. It's used in making very high speed computers. No resistance means everywhere we can use transmission of electrical power. So obviously we need some material so that it minimize the loss of transmission, because whenever we are making power, we are generating power to the power station or what we call thermal power plant or any power plant, there obviously when we have generated, okay, we have to transfer from one place to another. So there will be so many types of losses, like when we are using some um, electrical wires, there will be some losses due to like we can say transmission, like heat. Yeah, when we are transferring something, so there will be a heat produced because of flow of electrons, high amount of flow of electrons. So there will be a heat. So due to that heat, there will be a loss. Obviously, heat makes a loss. So due to that, there will be a loss in transmission also. That is about superconductor. Any doubt in this one? Camera? Come on, turn on a camera, everyone. Bhanuri, Devesh, Easter, Laukya, Rituraj, Samhita, Ajay. Make a note of it. Okay. Now see here, the question is here, see formulas we have to remember like this. RT is resistance at some temperature, R naught at 0 degree temperature. We have written here. Yeah, same formula here, like this, similar formula, 1 plus alpha T. Similar to this RT equals to R naught 1 plus alpha T. Now, alpha is the constant. So which will be given in question itself, like this value. So temperature coefficient, so it is given in question itself. See, 0.00125, it will be very, very small values. Alpha will be very, very small value. So you can say T equals to R naught 1 plus alpha T. So here, alpha T, T is not just this T, it is delta T, that means change in temperature, this is temperature coefficient, which will be in terms of inverse or this inverse, Kelvin inverse or centigrade inverse. Resistance at 0 degree, at some particular temperature. Now in this one, they have asked at 3000 Kelvin, resistance is 1 ohm. Sorry, 300 Kelvin, resistance is 1 ohm. At what temperature the resistance of wire will be 2. So one condition it is given that at 300 Kelvin, see, R naught value is not given, standard resistance is 1 ohm. At what temperature, at what resistance, R naught will be same here, 1 plus alpha T is 2. So if we take these ratios here, 1 by 2, 1 plus 27 alpha, I have subtracting from 273 degrees Celsius, 273 and 300 standard temperature. So I'll get 27 for conversion is 27. So alpha value is common. See, alpha value will be common here. If you do cross multiply, we'll get answer. See, in this one, R naught will be common, so we are just cancelling it. We're just removing R naught here. Done writing? Solve yourself.
Yes, sir, done.
What about this? Let's go next.
Sir, could you once scroll up?
Yeah, sure.
Done, sir.
Okay. This is like error and dimension analysis question. It's okay. Like let it be. Okay, this one we can solve. A wire has new resistance of 16 ohm. It is melted and drawn into a wire half its initial length. What will be new resistance of the wire? This question we have done in like the 10th standard also, similar question. See, remember one thing, it is melted. Okay, it is melted and drawn. So if it is melted and drawn, what will not change? Its volume. Volume will be constant. What will be answer? See, volume will be constant, remember? Volume will be constant. So volume is area into length. A dash, L dash. It's melted and wire is half its original length. So L by 2, what will be new resistance? So we have to check for area also. A dash will be 2A. So R equals to rho L by A. In that we can substitute L as L by 2, A as 2A. So it will become R by 4. Volume is constant here. Don't forget. Yesterday in 10th standard also. R by 4. That means 4 should be the answer. Yes. Did you get it?
Sir, could you scroll down?
This is actually shortcut way, but for understanding, we should know this way. As I wrote before, similar. Area will be changing because it's melting. It is not cut. If it is cut into two pieces, then we will not do this one. We'll directly apply. But it is melted. So that is why area will be changing. Melted or stretched or whatever. Understood? Guys, are you able to understand?
Yes, sir.
Okay. Madhusudan?
Yes, sir.
What about Banuri?
Yes, sir.
Okay. Esther, what about you? Esther, can you hear me? Okay. Laukya? This is an easy question.
Sir.
Okay. Rituraj? Done, right?
Yes, sir. Done.
ठीक है. Samhita, you too? Done?
Yes, sir.
Okay. One question we did for resistance. So same question, I want you to just write a question below question. This one. The current flowing through. Write a question and this two. Two questions I'm giving you as a homework today. After a long time, I'm giving you homework. So I want you to finish it. Just two questions. You can take screenshot or no, don't take screenshot because answer is also there. Write a question. Write this question and taken. Done both, wrote both the question. If you're done, we can end the meeting. But by the way, it is visible, both question. The resistivity of silver at 0 degrees Celsius is 1.6 into 10 to power minus 8 ohm meter. If its temperature coefficient, that is alpha of resistance, is 4.1 into 10 to power minus 3 Celsius inverse. Find resistivity of silver at 80 degrees Celsius. And next question, a current flowing through a wire depends on time as I equals to 3t square plus 2t plus 5 ampere. The charge flowing through the cross section of wire in time t equals 0 and t equals 2 seconds. So this is the range given. So what I said that day, current is given. You have to find charge. So I equals to Q by T, or I equals to dQ by dt. So we want dq. dq means dq equals to I dt. That means we will do integration. I dt. We'll substitute I value and we'll integrate. Okay? Try this as a homework. Okay, guys? Done writing?
Yes, sir.
Okay. Others? Madhusudan,
Yes, sir.
Bhanuri, Ajay, okay,
Yes,
done.
sir.
Laukya? Okay.
Yes, sir. Done.
Super.
Answer.
Okay. Okay, guys. Can I stop sharing? Okay, guys. Bye-bye, everyone.